Okay, so let's talk about systems of equations. A system of equation is when you have two equations that will graph a single line in a coordinate plane. A solution to this is where these two lines intersect. So let's just take a guess. Would 4, -6 be a solution? So if you're given the two lines and a point, all you have to do is plug in this for x and this for y to both equations and see if they work. So let's plug it into the first one. Does 4 plus -6 equal -2? Yeah, that's a true statement. But it has to be true for both of them. So we're going to next try the second one. 2 times 4 plus 5 times -6 equals 20. So this is 8 plus -30 equal 20. And that is not true. So 4 -6 is not a solution. So there's three ways to actually determine how to find the solution to a systems of equations, and we're going to talk about all three of those. Today is graphing. So in this lesson, we're going to talk about graphing two lines to see where they intersect. So let's say that I had x minus y equals -3, and I had x plus y equals 5. Now when I graph, I like to graph in slope-intercept form. So I want to solve both of these for y. So I would subtract x from both sides. -y equals -x minus 3. Divide by -1. Y equals x plus 3. Here I would subtract x. Y equals -x plus 5. So when I graph this, remember when you graph on a coordinate plane, you start at the y-intercept of 3, and then my slope is up 1 over 1. Now remember, these are going by a bunch of different ones. So up 1 over 1, and there is that line. And then on this one, I start at 5, and I go down 1 over 1. And so they intersect at 1, 4. So the solution to these two equations are 1, 4, because that's where the two lines intersect. Now, remember that when you graph lines, you have when you graph these two, you have 3 possible solutions. Your first is where they intersect, and it's one point where the lines intersect. Then you have no solution, and that happens when you have parallel lines. Remember, parallel lines have the same slope. I can't spell for nothing today. Parallel lines, they have the same slope. And then you have infinite solutions. And that's when they're both lines are the same. All right, let's try another one. So I have 3x minus 2y is -24, and -3x minus y equals 6. I'm going to solve both of these for y. Subtract 3x. -2y is -3x minus 24. Divide by -2. y equals 3/2 x plus 12. Here I would add 3x. Negative y equals 3x plus 6. Divide by -1. Y equals -3x minus 6. All right, so let's take a look at graphing that. I would start at 12. Now, it's going up 3 and over 2. These are going by 1. So up 1, 2, 12, 13, yeah. Up 3 over 2. Now, if you're doing it on your computer, it's going to be much easier to figure out where they intersect. I'm going to go backwards just because I can't see with these tiny little lines. Let me make this bigger. So now I'm going to go backwards, which means I go down 3 and over 2. Now the next one is it starts at -6, and that goes down 3 over 1. Down 3 over 1. And then draw your lines, and you'll be able to see it much easier on the computer, but the solution for this is -4, 6. Now, as you can tell, it doesn't line up to -4, 6, and that's just because my lines are off. Had I had I gone backwards, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, I would have ended up on that line. It's just graphing is the worst way to determine a system of equations. You would need better graph paper and a ruler, and I didn't have either one of those. So that's why it didn't quite look right, but when you're doing it on the computer, it won't be an issue. All right, so that is how to solve a system of equations by graphing.